Hey, welcome back again. My name is Jordan Deshawn, and in this video, we're going to be covering step 4, which is about pumping in the new Pumped Safe Water design tool. The first question to answer here under step 4A is what type of pump is being used? And you can click this drop down to see a few options: solar pump, AC centrifugal pump, and an AC centrifugal pump with inverter. For this example, we've gone with the AC pump with inverter. To select a pump, we want to use manufacturer pump curves to find a pump that can meet the design flow rate and TDH, which we just determined in step 3. So you can use a pump curve library for common water mission pumps that are used, or use a manufacturer's software like Grundfos Product Center, which is what I'll show in this video. To do that, we'll come to grundfos.com, hover over the Solutions tab, and then click on Products and Services. After that, on this page, we'll want to adjust the settings by clicking on the Catalog Settings button here. And you can select the frequency and potentially a country, but it can be good to select international. You may have options depending on the website you're using. And then for our frequency in this example, we want to choose 50 Hertz. Let me click Save Settings. And then we're going to scroll down to the section for Size Your Product here. We're going to size by application. The application area is municipal water supply. The application itself is groundwater intake. And then we can just leave this as borehole installation open tank. If you need to, you can pause this video as you're working through this yourself to follow these same steps. Next, click the blue button here, and it'll ask you then to enter your flow and head parameters for your project. Our flow for this example was 7 cubic meters per hour, and our head was 100.6 meters. Then we can click the Start Sizing button. Sometimes you need to click it twice to get it to go. So you scroll down, you can see we get a list of the 10 best matches for this flow and head. And then in this table, you can scroll left and right to see the various specifications and parameters of the pump options that are recommended here. You can see under the phases, we've gotten all 3-phase. That's one important parameter to examine. And the other important one to examine is the voltage, the rated voltage here, so that you can match what you need for your project. You get a list of the product names here. And then on the far left side, you can hover your mouse over these pump curves to see them a bit larger. And you can look at these to see which pump curve might be the most appropriate for your project. And for this example, the design engineer has selected the SP7-23 pump. So we can look at that more closely by clicking the product number here. So once on this page, we can see the Sizing Results tab, where we can see the pump curve and motor curve information. We can also come to the Specifications tab to see the specifications of this pump, such as the product number, product name, and then the rated power, rated voltage, and rated current. These are the important data points that we'll pull from this page to enter into our design tool. Let's look at that now. You can see we've entered the pump manufacturer, the pump model, and then the important specification data from the Specifications tab on the Grundfos website. Next, we want to also enter the pump performance at the duty point. So that's the operating point that we've entered. We can go back to the Sizing Results tab here and look at the pump curve to get that information. So under P1, we can see that's about 3.75 kilowatts. And then on this, we need to kind of look at that 3.75 kilowatt number to see what our rated current would be from this current curve, this I. That's the symbol or the letter for current. And then we'll enter that information here as well. And then in the next section, we're going to look at the pump performance and system curve. So to fill in these first two columns, we need to look at the pump curve on the Grundfos website. And we can get the pump curve data, which is, the pump curve is this blue line at the top. We can get the data by hovering our mouse directly over the points on the line of interest. So we can see this first point has a flow of 1 cubic meter per hour and a head of about 139 meters. So then in the tool, we've entered a flow of 1 and a head of 139 meters. We could then repeat this process for a flow rate of 2, 3, and so on throughout the rest of the pump curve, and fill in the rest of these columns for flow rate and head. It's important to also go from the lowest flow rate at the top to the highest flow rate at the bottom. Next is this treatment loss column, where you could enter the treatment loss for various flow rates in the pump curve. To get the treatment loss column, you can click on this blue link for the optional calculators tab, where it'll take you to see the treatment loss for the treatment method that you've proposed. If you're using a water emission treatment method, this can be automatically calculated in the optional calculators tab, which you can then just copy and paste into this column here. It's also acceptable to just leave this column completely blank. Finally, the system head is automatically calculated, and it's shown by this orange line here, the system curve. The point where these curves intersect is your operating point, which is about at a flow of 7 and a TDH of 100.6. Next, we do some pump checks where we enter the inner diameter of the borehole casing and the maximum diameter of the pump. And then this calculates the pump's cooling rate, which indicates the minimum cooling flow rate that's necessary, which then can dictate the minimum frequency required for your pump. Cooling is important to make sure the pump doesn't overheat, and if necessary, you can use a pump sleeve to improve the cooling. After that, we get to 4C, which is the power source checks, where you can select what type of power source will be used for the pump. We're using solar, and so all of the checks for the solar will be done in step 5. So we'll use step 5 to do those checks. If we were using a generator or a AC grid, if we selected one of those options, we would get fields that appear here for us to do checks for those power sources. Finally, we do inverter selection. If we're using a Grundfos pump, we're most likely going to use a Grundfos RSI, the renewable solar inverter. And you could do a similar search on the Grundfos website to find the appropriate inverter for your project. The 3 main criteria for your inverter is that to ensure that the inverter's current output exceeds the pump's current rating by a safety factor of 1.25, and that the inverter's rated voltage output AC matches the pump's rated voltage AC. And we also want to make sure the inverter's rated power exceeds the pump's rated power. So we can do these checks. We can see here that they appear in green, which means that they've been successful checks. They've met the criteria. If they appeared red, it might mean you need to increase the size of your inverter. Additionally, we enter the voltage input DC and for minimum DC voltage and maximum DC voltage. You can get these from the Grundfos website, but generally if you're using a low voltage RSI, those numbers would be a little bit different than this, but for a high voltage RSI, it goes from 400 to 800. Finally, we get a summary, which shows us the type of pump, the pump model. It looks like this error we might need to fix, And then the pump motor power. Similarly, we might need to fix the inverter links as well. So that's the end of step 4. If you have any questions, always feel free to reach out to me or any of the other Charleston engineers. We're always happy to help. But thanks for watching this video about pumping.